Good day, ladies and gentlemen. Today we are going to do the first module, which is climatology, and in which the learners, they don't do quite well. So we're hoping that by the end of this session that we are having, we'll be able to give a clear explanation so that our learners, they can improve, they score more marks in it. Unfortunately, it's the first module even in the paper, and seemingly everybody begins with that module, which is climate and weather. Now, I hope you all are able to see the smartboard, isn't it? Are you able to see the smartboard? Now, in the climate and weather, then, what we're going to look at, it's a mid-latitude cyclone. The tips that I want us to give our learners is that they need to be able to identify the stage of this weather disturbance. Of course, knowing there are other names, that it's a mid-latitude frontal cyclone, wave cyclone, or extratropical cyclone, because the examiner might use any of those words except the mid-latitude, so that our learners do not get lost. And maybe why it is called a mid-latitude, because it develops in middle latitudes. Why temperate cyclone? Because it is formed by two MSs, which is the hot and cold air. Why extratropical? Because they form 60 degrees and an extra distance from the tropics. And then why is it a frontal cyclone? Because it is developed by two MSs, where two MSs meet, and when they are separated by a zone called the what? The front. Now, they must be able to identify all the stages. For example, the initial stage, as you can see, they need to give the characteristic of, they must be able to mention the characteristic of the stage. As we can see there, you've got two MSs moving in opposite direction, separated by the zone called the what? The front. Now, you see now the formative stage, where you've got the warm air now, it's wedging, lifting the warm air. The isobars are beginning to form around the center. They need to be very careful. In a mid-latitude cyclone, we don't have the eye, but we've got the center. And then the V shape there is what? Is shallow. It is not deep, as you can see here. The V shape is just shallow. And then here is a very popular stage, which normally comes out in the examination, which is the mature stage. What are the characteristics? The two MSs, the cold front and the warm front, they are distinct. They are separate. And then also the V shape now is what? Is deep. It's not a question of isobars being less than one, in a mid-latitude cyclone, being less than 1000 millibars. No, they mustn't make that mistake. It's V shape which is deep, and the two MSs are what? Are distinct. It then identifies the mature what? Stage. And then we've got the occluded stage here, which is stage number 4. Stage number 4 is characterized by the two MSs meeting at the base or at the apex. As you can see from here to there, the warm air has now fused with the cold air. And then, of course, when you see here, those many diagrams, we've got mid-latitude cyclones connected to one another, and it's called a family. It's not a stage, this one. We call this one a family of cyclones, or a family of depressions. Normally, this family of depressions, it appears during the winter season, when the subpolar low pressure belt or the polar front is close now to the country of South Africa. And then let us move on now. As you can see there, the oldest one is occluded, and the mature one is this one, and then the formative one is this one. Now, why? Because they develop and they move from west to what? To east. So that is why the occluded one is the older one, and it's on the far east, because they develop from west to what? To east. Now let us move on now. They need to know that these are frontal depressions, extratropical cyclone, temperate cyclone, wave cyclone, so that when the examiner uses any of these names, they know it's still one and the same weather disturbance. Now let us come, they need to be able to identify and give characteristics of each stage, as I said before. The place of origin, where do they originate? At the polar front. What's a polar front? It's the middle latitude, 60 degrees north and south of the equator. Along the subpolar, or they say along the subpolar low pressure belt, or on the temperate regions. All these things, it's one and the same thing, place of origin. They can write any of those two. And then the frequency of mid-latitudes. Why do we have many mid-latitude cyclones during the winter season? And why do we have few mid-latitude cyclones during the winter season? Okay, the answer, the reason is that there is high frequency or many mid-latitude cyclones during the winter season because of the shift of the effect of the doldrums and other latitudes. There is shift during summer in the southern hemisphere. The heat, it moves, it migrates northwards, and 30 degrees migrates also northwards, and 60 degrees, which you can say is the disturbance in the western wind belt. And therefore, that 60 degrees in which they form during the winter season, it comes close to South Africa. And therefore, what is going to happen, mid-latitude cyclones, they are going to move across South Africa. But during the summer season, they are further south. Okay, we know that one. So this question was there, I think, in the June paper. They were supposed to say, there are many during the winter season because of the disturbance in the western wind belt, or the shift in the effect of the doldrums and other latitudes. Okay, let's move on. They need to be very careful about this mature stage. We can say it. You have got clockwise direction. It indicates the what? The southern hemisphere. Now, as you can see, now the air circulation now, circulating what? Clockwise. Learners must be able to have clear understanding. When you look at that movement, it only shows the air circulation within the cell. In the southern hemisphere, it circulates clockwise, and in the northern, anti-clockwise. But the whole cell, movement of the whole disturbance, it moves from west to what? To east. That air circulation is clockwise ascending also, and converging towards the what? The center. Now let's move on now. Here are the characteristics, as you can see them, the V-shape of a mature state. The V-shape is deep, the two MSs are distinct. Movement of the system eastward, west to east, because it is driven by westerlies. And the air circulation clockwise in southern hemisphere ascending and converging, which means it's moving inwards. Now, if the question is account for the position of the cumulonimbus clouds, and it says describe the gradient of the cold front and account for such gradients. Gradient of the cold front is steep, gradient of the warm front is gentle. Describe the gradient of the warm front and account for such gradient. Now let's go straight to the diagram because it explains everything. Now, here are the cumulonimbus clouds ahead or in front of the cold MS. Why? The question was account for the position of the cumulonimbus clouds. And the answer should be the cold air, what does it do? It wedges. When we say it wedges, we mean it goes underneath. Why? Because it is heavy. So as it goes underneath, it displaces the warm air from the ground. So the warm air is lifted. And then that is why you've got cumulonimbus clouds there. And then you've got heavy rainfall. Mid-latitude cyclones do not just produce rainfall. It's very important for learners to say it produces heavy rainfall. And then you look at the gradient of the warm front. It's gentle. It's not as steep as the one of the cold front. As it is gentle then, it's because of the warm air. The warm air does not shoot up, but it moves gradually up. So that is why now the warm air is light. That is why the gradient is what? Is gentle. Now, this is very important. Above here, I've got a cross-section of a mature stage of a mid-latitude cyclone. And underneath, it shows you what happens or what you see in a synoptic weather map. Now, let's look at this now. In a synoptic weather map, we've got the cold front and we've got the what? The warm front. And when we look at these two, they are distinct as they are distinct also in the what? In the cross section. Now, learners must be able to draw this diagram and put the positions of the what? Of the clouds. For example, showing that this is the cold front, when they draw this line of the cold front, they mustn't put these things which are underneath here, because it would not be a cross section. It would be, this is what appears on the synoptic weather map. A cross section will not have these triangles and these semicircles. So the first thing that they need to do, they need to draw the baseline. The baseline must be there. If the baseline is not here, they lose about 8 marks because the drawing is not a cross section. So they need to draw the baseline in bold. Make sure that it's there, because at times the answer sheet is the same color as the pen that they are using, and then now the baseline is not visible. So they need to draw the baseline and draw the cold front and draw the warm front in a cross section, and the gradient must be steep here and here it must be gentle, and they must indicate that this is the cold air, this is the warm sector of air. This one is not the cold air, but it's the cool, which means it's the air that is moderate. It is neither cold or hot. And then now they must put the cumulonimbus clouds here. They must put the altostratus and the nimbostratus here. So it will be light rainfall here, but here it will be heavy rainfall. And above all, they must put the direction, the arrow here on top of the diagram or below, which indicates the movement of the whole disturbance, that it moves from west to what? To east. Alright, as you can see now, when we describe this thing, this cross section, we've put the temperatures here on the one that is visible, or that is one that you normally see in a synoptic weather map. Now, if you look at the temperatures that are there, the cold air, it's 14, 16, 18. Yes, it's a cold air mass. So the air behind the cold front is cold. But ahead of the cold front is the warm sector of air. Look at the temperatures, it's 27, 24, 28, 28, 26, 24 degrees Celsius. So its temperatures are high in the warm sector of air. But in the cool sector of air, it's moderate, 19, 20, and what? And 17. Now, that is why when a mid-latitude cyclones move from west to east, let us say the place where you are here. So you experience temperatures between 19, 20 and 17. As it moves from west to east, the temperatures will do what? Will increase. So this 27, 26, 28 will arrive at you. So the temperature, the warm front, as soon as it passes, then the temperatures will do what? Will increase. Because the warm sector of air, it has got higher temperatures, and then the cold sector, when it arrives, the temperatures will do what? Will drop up to 18. So that is why we always say when a cold front passes, the temperatures will decrease. Now let us move on now. Now the analysis, sometimes the examiner, they play around the analysis, or you are expected to play just around the analysis. When you say the air ahead of the warm front is cooler, so the air ahead of the warm front, so air in the warm front is hot, 28, it is cooler, it's moderate, ahead of it, it's 18 degrees. The air behind, the air on the warm sector is hot, definitely, we saw the temperatures, they were high. The air behind the cold front is cold, yes, lower temperatures behind the cold front. And as the system moves eastwards, that is why temperatures, they do what? They change from being moderate to hot and then cold. Gradients, we've talked about them. Gradient of the cold air is steep because the air is heavy. And the gradient of the warm front, of course, is what? Is gentle. Now let us move on. Conditions of an active cold front. Please, must not make a mistake. In an active cold front, the cold air is behind the cold front. That's the only thing that I must say, if it's an active cold front. But in an active warm front, the warm air is behind the what? The warm front. Right, let us look now at the temperature changes that we've talked about as soon as this whole system passes. So we first experience the moderate air, and then we experience the warm air, and then we experience the cold air. The whole mid-latitude cyclone is moving what? Eastwards. So as soon as the warm front arrives or passes, as soon as it passes, the air was cool. So temperatures increase because the hot air, it arrives now. The pressure decreases once temperature increases. Wind changes direction. This is a formal question. What is the weather change? What are weather changes associated with the warm front? Of course, they can include that altostratus clouds are formed, and then there is what? Light rainfall. And then with the cold front, temperature decreases, pressure increases, wind backs. When we say wind backs, we mean wind changes what direction? If the mid-latitude cyclone is in the southern hemisphere, we say the wind backs. But if it is in the northern hemisphere, where the circulation is anti-clockwise, we say the wind veers. And then, of course, heavy rainfall occurs. Mind you, we didn't say rainfall occurs. We said heavy rainfall occurs. And then now we can come now to the occluded stage. Occlusion. We reach the occluded stage as soon as the MSs, they mix at the base or the apex. That's a characteristic of it. Now let's look at what happens when the occluded stage takes place. Now, the two MSs, they mix at the base. If it is a cold front occlusion, the cold air must be behind. As you can see in the mid-latitude cyclone, there is cool, warm, and cold air. Now, if it is a warm front, it's the cooler air followed by the hot air. But what do we say there? We say it's a warm front occlusion because it's the warm air that is behind the cooler air. But if it is a cold front occlusion, it's the cool air which is behind the hot air. So the hot air is leading the cold air. Now let us look at what happens when the occluded stage takes place. Right, the two MSs, they mix at the base. Whether it's cold or warm front occlusion, or warm front occlusion, yes. Now, the warm sector will narrow, or that would be a case of a cold front. So that sector which is in the middle is going to narrow, it's becoming smaller and smaller. And the occluded, it marks the stage when the weather disturbance, what does it do? It dissipates. In a mid-latitude cyclone, when it dies, because we don't say it dies, the geographical concept, we say it dissipates because it doesn't have life. Right, now let us look at the cold front occlusion. And mind you, and please bear in mind, in an occlusion stage, there is an acceleration of the air mass, not air masses. If it is a cold front occlusion, it means the cold air is behind. What does it do? It accelerates and catches up with the warm air. So the warm air is in front, this one that is behind, it increases, accelerates, it increases the speed until it catches up with the warm air. It first catches up with the warm air at the base, and when it has caught up with the warm air at the base, then now this warm sector, cold, this is the warm sector, cooler sector. This warm sector is going to narrow because this cold air will accelerate, increase speed until the overlapping there, until there is no more warm sector, until total occlusion is reached. And then the system then it dissipates, and the rainfall, what does it do? It subsides. So now be careful of the cross-section of an active warm front and an active what? Cold front. So this is a cross-section of an active cold front. Why? Because the cold air is the one that is touching the base. So advancing air is cold, we name it by the air that is behind. So now it's moving, and once this arm of the cold air touches the base, it's a cold front, what? Occlusion. But if it is a warm front, the arm of the warm air, it touches the base. So this air that is coming is hotter or warmer than the air that is ahead of what? Of it. Right? Let's look now at the weather associated with the cold front occlusion. Now when cold front occlusion takes place, the cold air accelerates and catch up with the warm air. The cold air then wedges, it goes underneath and displaces or lifts the warm air from the ground. The clouds are formed, and then precipitation over a wide area is experienced. Now let us look at the warm front occlusion. The warm air is behind the cooler air. So the hotter air is behind the air that has got less temperature. So it's the warm air in the warm front occlusion that accelerate and catch up with the cooler air in front of it. But now, the warm air now does not wedge because it is hotter. But what does it do? It overrides the air that is ahead of it, which has got lower temperatures than it. because it is lighter, the one that is coming from behind. Clouds are formed, and then you only receive light showers. Now let's look at the impacts now. What are the impacts? We need to use all these concepts because the examiner may use any of these concepts. So you need to know that impacts, effects, and results are the same. Now, there are environmental impact, there are social impact, and there are economical impact. It's very important that we explain to our learners that when you talk about environmental effects, you're talking about what happens on the environment. Social, what happens to the people. Economical, what happens to the economy. What are the results of the economy? Of course, there could be negative and there could be positive. Now, let us make examples now. What are negative environmental effects? Negative environmental effects of mid-latitude cyclones. We know that they bring heavy rainfall. What is negative about heavy rainfall? There is poor visibility, and that rainfall could also cause what? Floods. So that is what happens on the environment. Those are environmental. But if the question was asking about negative social impact, you need to say something about what is that is negative that happens on the people. So it's very important to link your answer to the question by also adding some of the words from poor visibility. What do you say? You say poor visibility, it causes accidents and people might also die. Now you have linked your answer to the question because now we're talking about the people. But you're using the same factor which was from environmental. For example, heavy rainfall, it displaces people. It displaces people, and once people are displaced, or you say crops are eroded, and then people have got less food. There must be people if it is social in your answer. Let's look at economical. Poor visibility can cause accident. It's not linked to economical. And now we need to continue your sentence. Say poor visibility causes accidents. Insurances pay out a lot of money, and the economy, what does it do? It decreases. Or you say heavy rainfall causes crops to be eroded. And now it's not linked to economy. But once now you add and say farmers lose a lot of money, then it is now linked to economical. So I've got all those results or impact or effects of mid-latitude cyclones. You can now be able to formulate a negative and a positive one. For example, on the environmental, dams are filled up, and sometimes the ecosystem is done what? It is disturbed, because even the animals that are small there, they might get what? Eroded by what? By water, or displaced by water from their habitat. While at the same time, we're talking about heavy rainfall. It could be positive because dams fill up. We've got more water for industries, more water for tourism spots. So just like canoeing, people now, the tourism industry, it booms up, it gets a lot of what? Of money. You can even link it now to the economy. Right, as you can see there. So this is a very popular paragraph questions for the examiner. But what is very important, every answer that you give, it must link to the question. If your question is twofold, it says, give negative environmental and social. Please let us tell our learners to put a small heading and say, environmental. They write 2 environmental effects and then 2 social effects. If it is, give 2 environmental and social effects in a paragraph. They need to have subheadings, environmental and social. Because if they write about environmental, our learners have got a tendency of looking at the initial part of the question. They don't read the whole question and say, hey, I've met this question before. Not having read the whole question, and then they write out of 4 instead of what? Of 8. They need to do well in the paragraph questions. Now let us look at the South African celebrity that gives up the what? The weather on daily basis on our TV. Now you can see there's a cold front there is crossing over the what? The country. Immediately you can tell which season is this one now. Because the cold front is moving across the country. Definitely this should be a what? A winter season, because they normally cross they come across and move across South Africa during the winter season. Now, suggest some advice, very popular question for the examiner. Suggest some advice to people living in informal settlements. Heavy rainfall. On heavy rainfall, once the mid-latitude cyclone is coming, definitely what you advise the community that is living in informal settlements to move to high-lying areas. And they must also put sandbags to avoid being flooded. On cold weather, because it's during the winter season, and that rainfall, it will be cold. They must wear warm clothes, they must prepare warming material, they must keep indoors. Because there's also a possibility of what? Of power failure. Suggest to people driving on high-lying areas. If people are driving on high-lying areas, more especially on the Central Plateau, and the cold front is coming, two things that are going to happen. Temperatures are going to drop and there'll be more rainfall, which can cause what? Floods. And then what do you advise them? From that poor visibility, their headlights must be working, fog lights must be in good what? Condition. Or we can say to them, they must avoid driving on high-lying areas. They must use their headlights and fog lights, which must be in good condition. They must be careful of mudslide. Heavy rainfall can cause mudslide because as soon as there is more water that is infiltrated, then mass wasting is going to take place. Of course, they must wear what? Warm clothes. Right, let's move on now to the second weather disturbance, which is the tropical cyclone. Tropical storms that develop on the tropics between 5 and 30 degrees north and south of the equator and differ on intensity, but usually we don't say they bring heavy rainfall, but they bring torrential what? Rainfall. They require Coriolis force. That is why they form from beyond 5 degrees Celsius, because Coriolis force increases as you move away from the equator. But between 0 and 5, it is negligible. It is so less in such a way that it doesn't cause that spiral movement. Continuous supply of moisture. Tropical cyclones depend on continuous supply of moisture because it's the moisture that sustains them. And with the temperatures, let us not only say temperatures above 26.5 degrees Celsius, let us say sea surface temperatures, because tropical cyclones, they only form over warm what? Oceans. And here are the information that we need to be clear about. Place of origin and localized name, requirements for formation of tropical cyclone, naming of tropical cyclone, categories of tropical cyclone, weather associated with tropical cyclone, effects, results, impact of tropical cyclones, whether they are negative or positive, whether they are environmental, social, or economical. And then comparison of effects on first world, rich countries and the third world countries. They need to know that. Comparison in recovery in third and first world countries, and the reason for their degeneration. We don't say a tropical cyclone, it reaches occlusion stage or it dies. We say it degeneration. We don't say a tropical cyclone, it reaches occlusion stage or it dies. We say it degenerates. And then of course, tropical cyclone, they can appear connected to one another. And then just like mid-latitude cyclone, where we said it's a family of cyclones. If it's a tropical cyclone, we say it's the Fujiwara what? Effect. Right? How do they form? Temperatures above 26.5, it creates instability, unstable air. The one that rises up should be a large low pressure area, which implies a large area which has got high temperatures. Upward movement of air that will cause cumulonimbus clouds to form eye walls around the what? The eye. Sea surface temperatures contribute to the energy, because that is where a tropical cyclone depends to sustain itself. So as soon as the tropical cyclone moves over the warm ocean, it becomes very strong and causes severe damage or catastrophic. We say it is catastrophic. And then coronary force, it causes the spiral movement. That is why we are saying it causes the shipwrecks. And you can say the corrugated iron on our walls, on our roofs, I mean, it becomes twisted in a circular way because of the Coriolis what? Force. So when they develop, the pressure must continually decrease, implying that the temperatures must continuously what? Increase for instability. Let us categorize them now. Category 1, they cause minimal damage. Category 2 cyclones, they cause moderate damage. Category 3, they are extensive damage. It blows the rooftops away and it uproot the what? The trees. Category 4, it causes extreme damage to that of category 3. And then category 5, they are disastrous, they are catastrophic, they cause severe damage, even life losses. Let us look now at the localized name. Localized name refer to what do they call tropical cyclone in different parts of the world. In Australia, east of Australia, or in Australia as they come from east towards Australia, they call them the Willy Willy. In India, they call them the typhoons. In America, they call them the what? The hurricane. And then east of Africa, we call them what? The cyclones. For example, Idai was a what? A cyclone. Let's look at this tropical cyclone. This is a satellite image of a tropical cyclone. When you look at that, you can identify the hemisphere in which this tropical cyclone is in, and you can also identify the stage. Now, one, you see here the movement of the clouds, the band of clouds. It follows the anti-clockwise circulation. So which means this cyclone is in the northern hemisphere, because in the southern hemisphere, they circulate clockwise. But here they circulate anti, which means northern hemisphere. And also here the eye, you look at the eye. The eye is well now developed, which means then that this is the mature stage. Let's look at the recent tropical, one of the recent tropical cyclone, which is Idai. Idai is between now Madagascar and east of Africa. So it has gone past Madagascar. Now you look at the clockwise circulation, definitely it's the southern hemisphere. And the eye is well developed. It is now in the mature stage. But it is still gaining strength. Its intensity is increasing because it is still over the what? The warm ocean. But as soon as it makes landfall, as soon as it moves over the land, then something is going to happen to it. Right? How do they gain strength? Moving or circulating over warm ocean. They gain strength from continuous supply of moisture. Also, the Coriolis force gives them the spiral movement. Once they reach hurricane strength, they become more devastating. Right? Let's look now at this mature stage of a tropical cyclone. When is it marked as it appears on the synoptic weather map? As soon as this innermost isobar, once it is less than 1000 millibars, then the mature stage is now what? Has been reached. Also, what you look here, you see here, this is the leading quadrant, is the one that is in front, which means this tropical cyclones move from east to what? To west. And also,
conference recording has started.
This leading quadrant has got severe weather. Why? Because this is where the winds are mostly violent. So it causes severe. So all areas that fall on this quadrant, they experience severe damage. Remember, this tropical cyclone can cover a distance of approximately 800 kilometers. So all areas that are here, as it moves from east to west, they experience the worst catastrophic weather conditions. Right? Let us move on. My arrow here. How? Right? Why is the leading quadrant not leading? Why is the leading quadrant having the worst weather? The leading quadrant has got the worst weather because that is where the winds are most violent. It is leading quadrant because the cyclone moves from east to what? To west. The leading quadrant is the one that is shaded in the previous what? Diagram.
Of a hurricane, wind and pressure drop suddenly.
Right? You look now at the cross, sorry? You look at, right, the leading quadrant is the one that is shaded in the diagram. So the cyclone is in the southern hemisphere.
Of a hurricane, wind and pressure drop suddenly. Calm and clear conditions are experienced with the passage of the eye. This condition lasts for 30 to 60 minutes and covers an area of plus minus 30 kilometers in diameter.
Okay, thank you. Here is a cross-section of a tropical cyclone. Now, as you can see here, this is the center of a tropical cyclone, which is, we call it the what? The eye. And around the eye, you've got upward movement of air, which is caused by high instability, high temperatures. That forms now the cumulonimbus clouds. The reason why you've got cumulonimbus clouds around the eye is because of the updrafts. Hot, rising hot air. And then the eye there, as it circulates in a clockwise direction, the eye is hollow there. So that is why you've got the cold air has got a chance of subsiding in the eye. Right? As you can see in this diagram now, here is the upward movement of what? Of air, forming the cumulonimbus clouds. It forms the eye walls. So here is the eye. These are the walls of the eye. Updrafts causing the cumulonimbus clouds here. And then the cirrus up there, and then the stratus below here. We've got surface convergence here. For a movement in a cross-section of a mature stage, surface convergence, upward movement of air, upper air divergence, and then there is descending air in the eye of a tropical cyclone. Now, look at different books, because a certain, or just from one diagram, the examiner might take the diagram that is not familiar to you. But you need just to look carefully. Still here you've got the updrafts causing the eye wall because of upward movement of air, descending air in the eye, surface convergence, and upper air divergence. So it's a cross-section of a mature stage. It could also be like this. Never mind. You know these things. Right, let's move now. Let us move now to the descending, let's move at the question. There was a question this year which had this diagram. So it shows a tropical cyclone in the northern hemisphere. Why? Reason number one, there is anti-clockwise circulation. There is anti-clockwise circulation, anti-clockwise and ascending air. This anti-clockwise, it says that this one is in the northern hemisphere. And of course, this cell now, if this is the dangerous semicircle, it means it's the leading quadrant. Now it's moving towards north. But if it was in the southern hemisphere, it was going to move towards what? South. For those two reasons, anti-clockwise circulation and moving towards north are the reason that it is in the northern hemisphere. As you can see here still, anti-clockwise converging air, anti-clockwise and ascending and also converging, and the cell is the leading quadrant is moving towards north. It's the northern hemisphere. Right, let's look at this one. Still it shows you that. Right, let's look at this one now. Questions on tropical cyclone. Describe 4 air movements. We've talked about them. Surface convergence, upward movement of air around the eye, upper air divergence, and downward movement of air in the what? In the eye. Describe the rainfall, wind speed, and cloud distribution across the tropical cyclone. I just want to go straight to the diagram here. The temperature, the wind speed, and rainfall across the tropical cyclone. The gradient is like this. On the outside of the weather disturbance, those 3, which is wind speed, temperature, and rainfall, they are low. But as you move towards the center, Those three, what do? They increase. Whilst they are what? They are low in the eye. Here is a map of southern what? Africa. Now what is happening now? When a mid-latitude cyclone, here is a mid-latitude cyclone, it's moving from west to what? To east. Right? Moving from west to east. When it moves like this from west to east, the South Atlantic High here, what does it do? It ridges. So it develops this thing, which is a what? A ridge. It bulges away from the high pressure cell. So there's a bulging from the South Atlantic High. So by bulging, it means the cold air is extended. And when this cold air is extended, it pushes further this mid-latitude cyclone, just like this. So the extension or the bulging, the bulging now is doing this thing. It's pushing now this mid-latitude cyclone. So the mid-latitude cyclone is here in the interior now of the what? Of the country. And then we have got also the South Indian high pressure cell here. And this high pressure cell is the winter season. It's well extended here over the warm ocean. Now what is it going to do? When this mid-latitude cyclone is moving further east, because of its movement of the cell and also the bulging of the South Atlantic High, it comes across this South Indian High. So this is the South Indian what? High. So the Indian High will block now the path, the eastward movement of the mid-latitude cyclone. So then this now South Indian High, it gets that weight that is now called a what? A blocking high. Why is it called a blocking high? Because it blocks the path of the mid-latitude cyclone. And then this mid-latitude cyclone is here in the middle of two high pressure what? Cell. It's somewhere, it's squeezed between these two. And then the piece now of this mid-latitude cyclone, it breaks off from the mother cell. So when it breaks off from the mother cell, then now it becomes stationary in the middle of the country for quite some time. And remember, we have got the anti-clockwise diverging air from the what? From the South Atlantic High. And this diverging air is from the warm ocean. So this warm ocean is now fed into this system. Which system? This cutoff flow. And it's stationary there for quite some time, and the warm air is fed. And once that situation happens, it causes now extensive rainfall, which can cause what? Floods. And more especially, the coastal areas are affected mostly. Coastal areas could be affected mostly, more especially, these areas, they could be affected mostly by this cut-off what? Low, as it causes extensive what? Rainfall. So a cut-off low, it's a piece of a mid-latitude cyclone which breaks off from the mother cell and becomes stationary there. Now, can we then proceed from the cut-off low and carry on? So this rainfall is very common, more especially during the winter time. As you know that these two cells have migrated what? Northwards. And the mid-latitude cyclone is moving across the what? The country. So it confirms that it happens during the winter season. Now let us move on now. The thermal low, we said the thermal low, it has got very little significance as far. Just knowing the names and I've been able to identify it if it's in the middle of the country. It's a thermal low, it's a heat-induced low, it's a weak heat low, and sometimes they call it the inland low. Now very little is said about it because it causes very little changes in the weather conditions. High pressure cells that affect the weather of South Africa, the Kalahari High, the South Atlantic High, we know this, these three, they've got a lot of cold sinking air. I like saying sinking air because that air is heavy. What does it do? It sinks, and therefore it's cold. It doesn't cause any clouds. That is why we've got drought during the winter season, because they are well developed, these cells, more especially the Kalahari in the middle of the what? Of the country. Right? And then we know the relief of the country. Once there is the Kalahari high pressure cell is present, then it causes a lot of subsidence. That's called sinking air. It pushes that inversion layer from central plateau to the escarpment. And when warm air from the east rises, it doesn't cool enough. It doesn't reach dew point temperature. And that is why, not that because we do not have rainfall. We need to say that is why winter is dry. We can't say that is why we do not have rainfall, because we're answering the question in a negative way. And we need to tell our learners to answer the questions in a positive way. Right, let's move on. Now, let's come now to, here is an explanation. During winter, Kalahari high is present. There is cold sinking air that pushes the inversion layer onto the escarpment. Cold sinking air, clear skies, or fair weather. So when warm air rises, it can't cool enough. The country becomes what? Dry. Can we move on? During summer, still in winter, the two anticyclones are close to the land or migrated northwards. We know that there are southeasterlies that converge at the equator. Yes. They've got little space because these high pressure cells are close to the land. Little space to pick up moisture. And that is why the country is dry during winter. And then also, this is a summer explanation. No Kalahari high pressure cell, no subsidence, no sinking cold air inversion is up. Warm air moves freely, it cools enough, and it forms what? Rainfall. Right? That's an explanation for summer explanation. Kalahari high is absent and hence weak subsidence of cold air, and inversion layer is far above the central plateau. Warm maritime air from Indian Ocean can ascend and cool to form precipitation, which is rainfall. Right? These two anticyclones also, they are far from the land. Southeasters can pick up moisture and bring rainfall towards the interior of the what? Of the country. That is why we've got summer rainfall. And in winter, it is what? It is dry. Let us come now to the line thunderstorm, the most popular question. Line thunderstorms caused by two anticyclones. It's very important for the learners, when they do this thing, they must have diagrams. They must have diagrams, they must know the anti-clockwise circulation from both this South Atlantic High and South Indian High. What do? They circulate anti-clockwise and they meet in the middle of the country. You look at this diagram, there you are. So now we've got two air masses now. We've got this warm air from anti-clockwise circulation from the South Indian High, and we've got this cold air from the anti-clockwise circulation from the South Atlantic High. And what do? They meet in the middle of the country, creating a diagonal line. It cuts the country into two, the diagonal line. And then what is going to happen? That is why we call it a line thunderstorm, because it develops in the form of a line. And then now these two MSs, they've got names now because they arrive here at the line from northeasterly direction. We call them the northeasterly, which are warm, and the southwesterly, which are cold. And then now a moisture front develops. So why do we call it a moisture front? Because the content of moisture in these two MSs, they differ. This warm northeasterly has got a lot of moisture from the South Indian High, from the Indian Ocean. And this one has got less or no moisture content. So that is why we call it a what? A moisture front. Front being a zone of separation. Then now let's move on. This storm happens when? During the summer season. Why during the summer season? Because these anticyclones or high pressure cells, they are there. So in the middle of them, in the country, there is a trough there. High pressure cell, and then there's a trough in the middle. So this trough, it allows the inflow of the northeasterly and the inflow of the what? Of the southwesterly. That is why it is. Because if it was winter, there wouldn't be an inflow of the northeasterly and southwesterly because there would be a high pressure cell there occupying the land with cold air. So now the inflow is allowed by the existence of a trough in the what? In the middle. Right, let us move on. Now, how does a storm develop then? Southwesterly, wedging, lifting the warm northeasterlies. And then extensive rainfall, but more extended towards the what? The east. Why? Because this cold air, it wedges. Then it pushes that warm air towards the what? The east. Right, let us move on. There is an explanation. Moisture front, because 2 MSs with different moisture content, northeasterly with moisture from Indian Ocean, dry from the cold Atlantic Ocean. Line thunderstorm because it's in the form of a line. Extensive rainfall accompanied by lightning and what? And thunder. And can cause what? Floods. The examiner now is very looking at that. It says, how does the line thunderstorm affect farmers? Now it causes what? Extensive rainfall. Extensive rainfall can kill the crops can be flooded. 2, light accompanied by lightning. The stock of farmers, people can die because of what? Of lightning. And also the floods, they can cause extensive soil erosion, which can remove what? Fertile what? Soil. Right, let us move on. There is an explanation. Crops can be destroyed by floods. Lightning can cause fire and burn crops. Stock can be killed by lightning. Farmers can be killed by lightning. They can cause soil erosion. But the most positive thing about the line thunderstorm is that the rainfall that it brings, although it can kill animals and farmers, but it breaks what? Drought. Because water is good for what? For crops. And dams can be filled up. And also, there'll be more water for domestic use. So it can have positive effect. There is a line thunderstorm when you look into a synoptic what? Weather map. Right, let's move now to the berg winds. Berg, Afrikaans word that means mountain. Please, berg winds. These are hot and dry winds. Now, where do they originate? During winter, there is this Kalahari high pressure cell well developed in the middle of the what? Of the country. And then on the coastal part, there is a coastal what? Low. Now, what normally happens? Winds will move from high pressure to low pressure. From the Kalahari high to the coastal what? Low. And when these winds move down the escarpment, they hit adiabatically. Their temperature, what does it do? The temperature increases of this air because of friction and compression. Friction, of course, it raises what? Temperatures. And friction, that is why when it is cold, people get close to one another. And they even hold one another. That is compression. And once there is that compression, because this cold air, it descends down the escarpment, it is heavy, it is compressed, and friction against it. That is why it hits at the body. By the time it reaches the coastal areas, it is very hot. Let us look at the descending air. Look at this diagram. It's descending from 1,000 meters in the central plateau. It is descending towards coastal areas. Look at the temperature. It was 19 when it was here. As it descended, it gained temperature. When it reaches the coastal areas, it is 26 degrees Celsius. How could these berg winds have brought temperatures in Vredendal? That's the question 2 years ago. How did the berg winds bring high temperatures in Vredendal, in the coastal areas? Because when it was descending down the escarpment, it was compressed and it had friction with the land surface. Its temperature increased. By the time it reaches Fred and Da, it had high temperatures, and that is how the high temperatures were brought towards what? Fred and Da. Now, what is very important is that for bergwinds to form, there must be two weather disturbances. The Kalahari high pressure cell must be present, and the coastal low must be what? Must be present. Right, and then, when you look at the previous diagram, most popular question, what weather disturbance normally follows or comes after the bergwinds? It's here. It's the cold front. It is approaching. You've got the bergwinds here, and then it is approaching, and then it's going to neutralize the high temperatures. And that is when the temperatures will drop, because once this cold front arrives here, it's normal. When I showed the synoptic weather map, or the map where our weather guy is presenting it on TV, there was the red, the big dot here, which was indicating the bergwinds. And the cold front was just behind that one. So it was coming. Always when there are bergwinds, what is going to follow is the cold front. Right, and then there is an explanation for all that here. I think we've done that one. Yeah, this is an explanation for that. And then, normally, coastal lows, they develop on the west coast. Coastal low. It's a low pressure that hugs, or that moves along the coast. Develops on the west coast, moves along towards the south coast, and then eventually to east coast. Now, what is very important about the coastal lows is that when it is on the west coast, you can only see that you've got the coastal low when you've got drizzle or fog. When you've got fog or mist. But when it's on the east coast, you will recognize it by having the what? The drizzle. Why different precipitation? On the west coast, fog or mist, because there is less moisture, because of the cold Atlantic Ocean. Why drizzle on the east coast? Because of moisture, because the ocean is what? It's moist. Right? So how does that happen? May I have the whiteboard, please? Right? Coastal lows being like this one here, and the coastal low being like this. Now we've got this one here, which we call the onshore winds. They are moving from sea to what? To land. And also here, the onshore winds. And then we've got the offshore that are from land to what? To sea. And this is the offshore. So why do we have different precipitation? The onshore winds here, they bring what? Moisture. Because they come from the warm ocean. And these are dry. So when they are circulating in a clockwise direction, because it's a low pressure cell, these onshore winds, they bring a lot of moisture. And then that is why this side we've got what? We've got drizzle. But here, these onshore winds, which we expect, because they are from water, to have what? Moisture. The ocean this side is what? Is cold. So there is no moisture. So that is why here, this side you've got what? You've got fog, or you've got what? Mist. So that is the coastal low and its effect. So normally the air in these two, or in this one cyclone or pressure cell, it is dry. Even if there was a weather station that would be here, let me say there's a weather station that is here, and then we take it up here, and then we do this. We show it like this. The air temperature can be 27 degrees Celsius, while the dew point temperature is what? Oh, sorry, it's on the east coast, this one. You can have, let's say, okay, you can have here what? 21, and then it's going to form fog here, or what? Or mist, because of moisture. But if the weather station is somewhere here, this is what you can have. a weather station, and then you can have here 27 degrees Celsius, while the dew point temperature is what? Is 5. So if you look here, the precipitation that will be formed here, it will be formed. And you look at the cloud cover, there are no clouds. Why no clouds or minimal clouds, if there are? Minimal clouds because the air that ascends, it does not have moisture to form what? Clouds. So the air will be hot, but it will be dry. No clouds. That is why coastal lows do not form what? Rainfall. They can only form fog on the east coast because of those factors. Now let us move on now. Right. Here's an explanation. Right. Can we move on? Here is the aspect. Please let us be careful with our learners. The aspect definition is the side of the slope that faces the sun. It has got nothing to do with the angle. Once they put angle, it becomes wrong. I know some of the books, they say it's the angle at which the sun rays strikes. No, it's the side of the slope that faces the sun. It receives more insolation. And then the one on the shadow side. Normally, the problem in learners is this one. I've observed it. They find it difficult to understand this, but maybe one needs to break this one, or gives the whole, and then we can break it up. I'm going to make a drawing here which will show the whole of this. Let us say now you've got a situation like this. Because the surface of the earth is undulating, which means it is not flat. Right, we've got this situation. And then we say here, this is the northern what? Hemisphere. And this is the southern hemisphere. And here, you've got what? The sun. What is it doing? It's giving this. And it's giving this. And it's giving this. And it's giving this. And then what do we have? So, this slope is facing the sun. Let's say here is the equator. The equator is somewhere, it's 0 degrees. Northern hemisphere, this slope is in the northern hemisphere. It is facing what? South. Normally what you're going to discover is that this one can record 40 degrees what? Celsius together with this one, 40 degrees Celsius. It's near the equator and it's facing the sun. And you find that this one is recording what? 32 degrees Celsius. And this one is recording 32 degrees Celsius. It's facing the sun. But the slope that is close to the equator, this one is recording 10 degrees what? Celsius. And this one is recording 10 degrees Celsius. Why? Because it's on the shadow side. Why? Because it's on the shadow side. So that is why in the southern hemisphere we say north-facing slopes are warmer than south-facing slopes. And in the northern hemisphere, the south-facing slopes, they are warmer than north-facing slopes. Shadow side here. And here it's also the what? The shadow side. Normally the examiner does this. The examiner would just take this one and say, this slope is 60 degrees south of the equator. And say this is the north of the slope and say this is the south of the slope. If the examiner did not say so, he will say this is the south of the slope and say this is the north of the slope. And then the learners must be able to see that this one is facing the what? The sun, and this one is facing away the sun. Although this one is far from the equator, but it will receive high temperatures because it is facing the sun. And this one is close to the equator but facing away, and then it will be on the shadow side, and hence less what? The examiner normally does not give this whole diagram, but will simply just choose the slope and say this one is in the northern hemisphere and say this is the south of the slope and this is the north of the slope. So they must be able, when they given a value like this, they must be able to take it from the bigger drawing. And also you can make even this drawing like this and say you've got a situation like this and say like this and say like this and say this is your equator and do this and do this. Can you see here the sun rays? They're just like this. They're like this. They're like this. So, and say this is the northern hemisphere, and say this is the southern hemisphere. So this face slope is facing what? North. It will be warmer than this one that is facing what? South. And this one will be warmer than this one, which is facing away, which is on the shadow side. So in the northern hemisphere, south-facing slopes are warmer than north-facing slope. In the southern hemisphere, north-facing slope are lower. There you are. And then, further, because we need to consolidate the information that we have. Otherwise, our kids must be able and not say, oh, we learned this in climatology, and therefore it is not useful in map work. No, or it is not useful in fluvial what? Processes. I'm going to make an example of other question. Right. And then what does the examiner say? The examiner says this slope or this valley is in the southern hemisphere. And then he says this one is slope what? B. And this is slope what? C. And then do this. And say this is the north of the slope and this is the south of the slope. 60 degrees what? South. Now we look at this. So which slope is suitable for forestry? There's a difference between a forest and forestry. A forest is natural, but forestry, that is when you plant trees. Now this slope is suitable for the forest, the one that is on the shadow side, right? This one is suitable for the forest. And this one is suitable for plants which need a lot of sunlight because the sun rays will be like this. So slope B will be suitable for plants that need what? Plants that need what? Sunlight. So this one is suitable for the what? For the forest. Right? Why is this one suitable for the forest? Because it's on the shadow side. Trees need a lot of water. And also the shadow, there is less evaporation that take what? Place. And also, if it is a valley like this, it is ideal for cutting the trees. Because the trees, they don't grow like this. They grow, vertically up. So how is it suitable for felling the trees? Because what you normally do, you cut the tree here. You know it falls this way. It falls this way. It falls this way. There'll be less accident. But if it's on a flat area and you've got a forest and you cut it, the tree can fall to whatever direction. Okay, let's move on. Here is this temperature inversion. Please. What is temperature inversion? Temperature inversion I just want to make sure about this one and put the diagrams at the side. Temperature inversion. What I say to my learners, they know the four basic operations: addition, subtraction, multiplication, and division. And normally when we talk about the inverse operation of addition, we say it is subtraction. And the inverse operation of division is multiplication. So the opposite. So when we say temperature inversion, what everybody knows this, even a person that is not doing geography. What do they say? They say the higher you go, the colder it becomes, right? So which means when you increase altitude, the temperature, what does it do? It increases. It's true. It's normal. That is why we call the higher you go, the colder it becomes. We call it normal lapse rate because we expect the temperature to drop when we ascend or when we move to high altitude. Then, when we say now temperature inversion, so it's the opposite now. Because in temperature inversion, what do we say? We say the higher you go, the warmer now it becomes. Because it's something that we do not expect. It is inverse of what is normal. So here, when we increase temperature, it becomes hotter and hotter. That is what is called temperature inversion. The higher you go, the warmer it becomes. Or When you increase altitude, the temperature also a dome structure. So a dome structure is like this. Okay, let me erase this one. Right, so that you can see. So if the higher you go, the warmer it becomes, or when you increase altitude, the temperature increases. We find it on 3 instances. That is why at times you find a situation that in your books it is like this. As we saw those gradients, the higher go, oh let me use the green one, the higher go, the colder it becomes. But when it comes here, the temperature increases. And then we've got this situation. And also here, the higher go, the colder it becomes. But when it is here, and then it's like this. That is why it is like this, even in the books. So this dimension which goes this way, it shows that the temperature of the air, when it arrives, is this altitude, it increases. Now, number one, let's look here. In a valley, the warm air is heated and it rises against the slope and it accumulates on top of the valley in such a way that when subsequent air, the air that comes after that one, it reaches this level of this blanket-like layer now which is accumulated on top of the valley. Instead of it losing temperature, when it arrives here, it gains temperature. And above that, it will lose temperature. But when it is here, it will gain temperature instead of losing it. And also, this is the same that happens here in the thermal belt. The air loses temperature when it's here, but when it's here in the thermal belt, it gains temperature, and then it will lose temperature also. And also in a pollution dome, a layer of pollution that is found on top of the settlement, where you've got the Kalahari high pressure cell causing subsidence, pushing this pollution layer, an upside down bowl-shaped layer of pollution found on top of a settlement. There's subsidence close to the city top. The air rises, but when it is here in this layer, its temperature increases. And then after that, it will be like that. So temperature inversion means the higher you go, the warmer it becomes. It happens on 3 instances. Thermal belt, on top of the valley, and on the pollution what? Pollution dome. Right. There's an explanation. Increase of temperature when increase in altitude, negative latitude. It happens on top of valleys where there's an inversion layer. It happens also on top of the thermal belt. And also, oh, there you are. Can you see that? If one were to annotate this and put the graph here, it's the higher go. Oh, sorry. The higher go, the colder it. Right. The higher you go, hey, my whole board is moving. Just want to annotate those graphs so that you can see. I won't. Carry on. Now, there. Now, the higher you go, the colder it becomes. But when it is here, the higher you go, the warmer it becomes. And then the higher you go, the colder it becomes. Now, in a thermal belt, frost pocket, whatever, we can do the frost pocket, we can integrate it with the thermal belt. But let's talk about the frost pocket. It's a layer of thin warm air found in the middle, that develops in the middle of the valley. So what happens here? During the night, the cold air drains into the valley, katabatic winds against the slope. And when they arrive at the base of the slopes, they displace the warm air. Why is it the warm air during the night? It's because the soil surfaces here, they absorb Sorry. Oh, they absorb water fast and release it fast. And here you've got the moisture content, water content, which retains heat for quite a long time and releases it during the night. So that is why the air above, the moisture content air, it releases it at night. So that warm air is displaced and it accumulates on top of the valley. And is also called air, which then pushes that inversion layer and it develops in the middle of the what? Of the slope. And then creating, that is why we call it an inversion. There is temperature inversion taking place here. And how does it affect human activities? Settlements will be here because people like warmer climates. And also they will plant here because their crops might be killed, might be destroyed by what? By warm air. Sorry. Right? So that is how it affects humans. But most interestingly, there is a question which says, how do katabatic winds form? Katabatic winds form this way. The temperature here on top of the valley, what does it do? It decreases. And then when the temperature decreases, a high pressure is created. And then the wind will move from high pressure because this air will descend because of gravitational force. It is heavy now. That is why it drains onto the valley. Now when this air now from high pressure drains into the valley, then the katabatic winds are what? Are formed. I think this question was somewhere, it's a year or 2 years ago. How do they? Right, let's move on. There's an explanation here. How does the thermal belt influence? We've talked about that. Okay. How are katabatic winds formed, as I explained. How are anabatic also. It's very simple. Let us come now to the heat island. Heat island, high temperature separated. It's not enough for our learners to know the causes. And when they mention these causes, for example here, they know the causes, but they also have to know the how part. How do artificial surfaces increase temperature? How do high buildings increase? How do industries? How do many cars? For example, if one were to pick here, we've got cement buildings which are artificial. It's not enough for them to say they trap the heat. No, it's not enough. It's not enough to say to the tar roads they absorb heat. They have to say the tar roads absorb and radiate heat. Cement buildings absorb and radiate the heat. Because otherwise the city center, tar roads would absorb the heat, while the plants also on the rural areas, they absorb the heat. And therefore, what would make the difference? In the city center, it's absorption and radiation. There on the rural areas, plants and vegetation absorb the heat and use it for the process of photosynthesis. So the how part is very important, not just knowing the factors that causes the what, that cause the what, the difference. Right, there we are. Please, our learners, this diagram, you ask them what are these lines, they say they are condo lines or isobars. These are isotherms. Condo lines, isotherms, isobars, isotherms, isoheights, isoplates are different. Now these are isotherms. Now, very interesting questions. It shows the difference. Temperatures are high here. 36, 34, 32, 30. The isobaric interval is 2 degrees Celsius. And when you move now away from the city center, the temperatures, what are they doing? They are decreasing. Now there will be a drastic drop here because now you're beginning to have what? Vegetation. And it could be 18 here degrees. Why? Because now the vegetation, it cools the area. But when you look at this one, why are the isotherms not circular? Why are them elongated towards the east? They are elongated because they follow the height of the buildings. The buildings are high and then the temperature will be high. because of multiple reflection and because of course that these tall buildings, they act as windbreaker. The horizontal wind cannot take away temperatures, which is in the middle of this what? Of these buildings. And then there is a pollution dome here. Pollution dome is close to the city top during winter and during the night, but it is I just want to explain this one. Let's just explain this one. Because it causes problems in the examination. You know, the drawing is just evaluated by just one thing that they'll have to do. Now, thank you. Oh. Here's a pollution dome close to city top. And also here is another pollution dome away from the city top. Now, this question that came out in the exams, it's most popular. You look at this. If they draw the night and winter situation, it has to be like this. This structure must be close to the city top because, and they must put the arrows like this, showing that this air which is rising, it is blocked by this layer of pollution. But if it is like this, it would indicate a what? A day or summer situation. Why? Because during summer, there is no Kalahari which causes subsidence, so the warm air it moves freely. And during the day, there is a lot of warm rising air. There is no cold air that would descend. But here, the closeness would be caused by this, which produces. They must even put this when they are drawing the winter, just to show. And when the arrows are straight here, it's enough evidence that there is weak subsidence. But if the arrows they bend like this, they also show that it's a night situation because there is subsidence, winter and night. So they need to be very careful when doing these drawings. Right, here are the differences. City center arrows absorb and radiate. Geometric structure cause multiple reflection. And also artificial heaters. And also automobiles, these are cars. What do? They emit greenhouse gases, which are responsible for the increase in what? In temperatures. Difference in rainfall between the city center and the peripheral rural areas. There is more heat in the city center. There is less heat here because of vegetation. Difference in climate, I would say. And then here you've got more rainfall because of the hygroscopic particles. Those are minute dust particles. They make it easy for raindrops to form in the city center. And then in the peripheral areas, although there is a lot of moisture, you see there is less moisture in the city center, but there is more rainfall. And here there is more moisture, but less rainfall. Because here, although there is a lot of moisture, but there are no hygroscopic or minute dust particles that enable the raindrops to be formed around there. Right? When the question is calculate the range, take the highest temperature and minus where the highest temperature, where the temperature in the rural area, the highest temperature in the rural area. Right, and then we'll get the range. How to reduce heat in the city center? Create water bodies, create parks, reduce cars in the city, because the city they emit greenhouse gas, put green belt, put city gardens, put roof gardens, paint buildings with bright colors. Right. Let's move on. There is that drawing which I was talking about. There is that drawing. So the air here, what does it do? It's turning now because the pollution layer is close to the city top. It's wrong here to say it's the day. Alright, let us come now to radiation fog. As it says radiation fog, it's a fog that is caused by the heat that is given off by the what? By the air. It happens during still clear nights. When we say still, there is no wind. Clear, cloudless winter nights. So what normally happens? The cold air, it drains into the valley, as we saw in the night situation in the anabatic and katabatic winds. Strong winds will drain into the valley floor, displacing the warm air. And once this warm air rises, the anabatic in the middle of the, it reaches dew point temperature close to the valley top, and it creates fog on top of the valley. In Zulu, we call that fog on top of the valley umlalamvu. And that valley is going to be observable in the morning, although it formed during the what? The night. Come day situation, the sun rises. The valley sides, what does it do? It absorbs the heat and radiates it. And once it radiates that heat, the fog will clear from the bottom. Ibisele, while it remains on top, it will clear like this until. It's nice when you watch this thing in the morning when the sun comes out. You'll find that you've got the fog, the one that is below, it's diminishing. You know, from bottom to the what? To the top. Why? Because of earth radiating the what? The heat early in the morning. So that is the situation. Let's move on. Pollution layer definition, learners must not forget upside down bowl shape layer of pollution found on top of an urban settlement. Of course, with also the changing position. Smog. What is smog? Definition, combination of smoke and fog. Winter situation, high amount of smoke. Why? There are more warming materials, there are more fires because of dry vegetation. The Kalahari high pressure has got cold sinking air. It pushes all the pollution. And you find that the settlement, there's even poor visibility during the night, during the winter nights, because the smog is trapped there. And learners still have got to do this. Learners must be able to analyze this, because the examiner might put a graph. A graph with a 24-hour like this. I'll simply just do a drawing which gives a clue and say this is 12 noon. 12 noon, yes. And 2, 4, 6, 8, 10. And here it's 10, it's 8, 6, 4, 2. This is, what are we going to say here? Let's say this is the day and this is the night. If it's a 24-hour, it is going to be 14 hours, 16 hours, 18 hours, 22 hours. And then, wait, 22. And here it will be 24. So this would be 12 midnight, right? 12 and then 2 here. In the morning, early in the morning. So the graph of smoke concentration over an urban settlement would be like this. You see, by 2 o'clock, industries are inactive and the automobiles, cars and everything. But by 4 o'clock, it will begin to do what? To rise. And by 8 o'clock, there is a lot of smoke. And then it will decrease by 9 o'clock. And then during the day, cars are parked. And the machines are warm, they do not emit smoke anymore. And somewhere by 4 o'clock to rise, by 6 it will be like this, and then it will decrease. And then inactiveness of the industries during the night and cars. Why do you have maximum smoke at about 8 o'clock? The cars started at about 4 or 5, 6 o'clock in the morning emitting smoke. It was gradually moving up And by 8 o'clock, we've got the maximum of smoke, which then is reduced drastically as the cars are parked now at work. And the machines are warm, they no more emit smoke. And then from 10 o'clock up to 2, 3, close to 4 o'clock, people are knocking off at work. And then, what do? It decreases. You'll have less during the night than during the what? Midday in the afternoon. Why? You know, when you start a car, when the temperatures are very low, it emits a lot of smoke. But when it is hot, temperatures are a little bit higher, it doesn't emit a lot of smoke. So you can justify the maximum smoke between 8 and 9 due to the traffic and the beginning of the industries to do what? To function while the machines were what? Were cold. So here's the explanation. They must be able to analyze the graph, because the examiner can say at what time was the maximum smoke, or what was the maximum smoke, or what was the peak smoke, maximum, highest amount, maximum smoke. And then they need to put their rulers, although it is approximation. Let's teach them to put the ruler 8 o'clock this way, and then look at the y-axis and read the amount of smoke. Now let's carry on. Interpretation. Please, we want to have a question like that, which says, where is the wind going? Wind is named according to the direction from which it flows. That's a policy. You can't ask a question which says, where is this wind going? Because it might be deflected a few meters from its origin by the gradient. Pressure gradient force, you remember, or the Coriolis force. It might deflect it. So let us stick to the same principle, that we look at where is the wind coming from towards the what? The station. And they must also be able to interpret synoptic weather map, identify, name weather disturbances. Right? They must also be familiar with satellite images. As you can see here, it's better to identify a mid-latitude cyclone with that clockwise and inward circulation. Look at the band of clouds following the clockwise what? Circulation. Right, let's move on. This is just a definition of pollution dome. We've talked about it. Cold snap. The examiner must ask you, what is called a cold snap? A cold snap would be, if they say South Africa will be affected by a cold snap, it means there is a cold front that is coming. They are referring to the cold temperatures that will be catching up with them. And then the heat wave, that's a period when we've got extremely high temperatures, and we call it the what? The heat wave. We normally experience the heat wave during the summer season. May God assist your learners in performance in the examination. Thank you very much. Not unless if there are comments, questions, or whatever.